Welcome to the deep dive. We got this great set of practice questions for the Juniper JN0-750 exam, and we figured this is a perfect way to really dig into some key Juniper networking concepts.
Yeah, absolutely. Think of it like a quick tour through the fundamentals.
Exactly, a shortcut to understanding what makes Juniper networks tick.
And we're not just, giving answers. We want to explore the why behind them.
Right.
So even if you're not prepping for this specific exam, these principles, they're super relevant for anyone working with Juniper gear and enterprise networks. You'll definitely pick up some useful stuff.
Okay, let's dive in. First question gets right into dynamic routing. It asks, which protocol is used by Juniper routers for dynamic routing in an enterprise network? Options are ICMP, OSPF, FTP, SNMP.
Well, OSPF jumps out immediately, doesn't it?
It does. Open shortest path first.
Right. The question specifically asks about dynamic routing in an enterprise setting, and OSPF is a classic link state protocol built for that.
Yeah, and the other options.
Well, they're different beasts entirely. ICMP is for diagnostics like ping, FTP file transfers. SNMP is for network management, monitoring devices. None of them are about actually calculating the best data paths.
Makes sense. So the explanation confirms OSPF is the one, highlighting its job in finding efficient routes on Juniper gear. The core idea here is really routing protocols in general, yeah.
Exactly. They're the languages routers use to talk to each other and figure out where to send traffic.
And dynamic ones like OSPF automate that.
Precisely. Instead of manually programming every route, which would be a nightmare on big networks, these protocols let routers adapt on the fly to network changes. Super important for complex enterprise setups.
You mentioned OSPF builds a map of the network.
Yeah, that's the link state part. It gets a full picture of the topology, which lets it make smarter path choices compared to older protocols that just relied on what their neighbors told them.
Got it. Okay, question 2. This one's about resilience. Which feature of Junos OS allows for automatic recovery from a failure in an enterprise network? Choices: STP, HA, IPsec VPN, RIP routing.
This points pretty clearly towards HA. High availability.
High availability. Makes sense, contextually.
Yeah, think about the bigger picture.
Yeah.
Networks need to stay up. Downtime costs money, causes headaches. HA is all about building in that robustness.
Right. And the explanation says HA in Junos is specifically for that automatic recovery. One device fails.
Another one takes over. Seamlessly, ideally. Minimizes disruption, like having a hot spare ready to go.
So the underlying concept is network availability and redundancy.
Spot on. HA is a mechanism to achieve high availability. And redundancy, having backup parts or paths, is what makes HA possible. Junos has different ways to do HA too, so understanding the specific implementation matters for failover.
Okay, good point. Question 3 takes us to the CLI, the command line. In a Juniper network, which command displays the routing table for a specific interface? Options: show interfaces, show IP route, show routing table, and show route.
Okay, for Junos, it's show route.
Show route. Interesting. Not show IP route like some others.
Nope. Junos has its own specific syntax. Show route is the standard way to see that routing table.
And the explanation backs that up. It shows you everything the router knows: dynamic routes, static ones, directly connected networks. So the core idea is routing and traffic flow. And this command is how you peek under the hood and see the actual paths.
Exactly. You need to see that table to understand how traffic should flow and to troubleshoot when it doesn't. It's crucial for diagnosing issues, checking configs, a real cornerstone command for anyone managing Juniper devices.
And you mentioned seeing preference values in the output.
Yeah, that's key. Lower preference means the router likes that route better. It tells you how it's making decisions when there are multiple paths to the same place.
Very useful. All right, question 4. Shifting gears to security. Which security feature controls traffic flow and restricts unauthorized access on Juniper routers? Options: NAT, VPN, ACLs, BGP.
This one has to be ACLs, access control list.
Access control list, okay.
Yeah, it ties right into network security. ACLs are like your firewall rules, but right on the router interface.
Like bouncers at the club door.
Yeah.
Checking IDs.
Yeah, that's a pretty good analogy. They look at traffic source IP, destination IP, ports, protocol type, and decide based on the rules you've written whether to let it pass or drop it. Essential for locking things down.
So you use them to stop unwanted access and control what goes where.
Precisely. Now, the other options are security related too, right? NAT hides internal IPs, VPNs create secure tunnels, BGP can have security features, but ACLs are the direct packet level traffic cops on the interfaces. Very granular control.
Gotcha. Okay, next up, making changes stick. Question 5. What's the primary function of the Junos OS commit command? Options: create backups, apply config changes, display interface stats, or configure routing protocols?
Ah, the commit command, fundamental to Junos. The answer is to apply changes made to the configuration.
Apply changes. So you type stuff in, but it doesn't actually do anything yet.
Not until you commit. That's the interesting part of Junos config. It's a two-stage process. You build your candidate configuration.
And then commit makes it live.
Exactly. The explanation nails it. It's like hitting save after editing a document. The underlying concept is configuration management.
And it's a safety feature, too.
Absolutely. Big time. It lets you review everything before you potentially break something. And there's even commit confirmed.
Oh, yeah. What's
So
that?
you type commit confirmed, say 5 for 5 minutes, the change applies. But if you don't type commit again within 5 minutes, the router automatically rolls back to the previous configuration.
Wow, okay. That's a lifesaver if you accidentally lock yourself out or something.
It really can't be. Saved many admins, I'm sure.
All right, question 6 moves into automation. Which Junos OS feature helps automate network configuration using scripts? Options: dynamic routing, CLI, Junos automation, SDN.
This one's pretty straightforward. Junos automation.
Junos automation. Makes sense.
Yeah, and think about how crucial automation is becoming. Networks are just getting bigger, more complex. You can't manage it all manually anymore, not efficiently anyway.
Right. The explanation says it lets admins use scripts for repetitive tasks and configs, saves time, reduces errors. The concept is clearly automation and scripting.
Definitely. And what's neat about Junos automation is the flexibility. It supports tools like Python, Ansible. You can interact with the devices programmatically.
So it's not just built-in scripts. You can use standard automation tools.
Exactly. Makes it easier to integrate Juniper gear into larger automation workflows, much more efficient for deployments, consistency, all that good stuff.
Okay, question 7. This one seems interesting and asks, which protocol routes traffic between multiple routers within an autonomous system? Options are EIGRP, BGP, OSPF, RIP. The answer given is BGP, but hang on.
Yeah, I see where you're going. The explanation probably says BGP is for interdomain routing, right? Between autonomous systems.
It does. It explicitly says between ACs. But the question asks about routing within an AS. That seems like a mismatch.
It absolutely is a point of potential confusion. You hit on a key distinction. While technically you can run BGP inside an AS, we call that IBGP, its primary design, its main purpose, its bread and butter, is routing between different autonomous systems. That's interdomain routing.
So for routing within an AS, you typically use something else.
Usually, yes. Like OSPF, which we already talked about, or maybe ISIS. Those are interior gateway protocols, IGPs, designed for routing inside a single administrative domain inside an AS. BGP is an exterior gateway protocol, EGP.
Okay, that's a really important clarification. So listeners, while the practice question might say BGP here, remember its main role is connecting the big pieces of the internet or large organizations together. Inside one organization's network, you're more likely looking at OSPF or ISIS.
Exactly. Terminology matters here. BGP is all about policy and connecting these distinct networks.
Good clarification. Let's move to question 8, monitoring. In Juniper networks, which tool monitors and troubleshoots interface errors and link status in real time? Options: NetFlow, SNMP, Network Performance Monitor, Junos Space Network Director.
For a Juniper-specific tool providing that kind of real-time visibility, it's Junos Space Network Director.
Junos Space Network Director.
Yeah,
Okay.
this falls under network monitoring and troubleshooting. You need tools to see what's happening, especially when things go wrong.
And the explanation says Network Director gives that real-time view of interface status, helps spot errors, performance issues. Sounds pretty comprehensive.
It generally is. Tools like Network Director often pull together data from various sources. They use protocols like SNMP, maybe NetFlow data too.
So SNMP and NetFlow are more like the data sources.
Often, yeah. They collect the raw information. SNMP gets device stats, NetFlow tracks, traffic flows. But a platform like Network Director takes that data, analyzes it, and presents it in a useful way. Dashboards, topology maps, alerts. It's the higher-level management and visibility tool.
Makes sense.
Okay.
Question 9, preventing loops. What's the function of spanning tree protocol, STP, in an Ethernet network? Options: assigns IPs, encrypts data, ensures optimal routing, or provides redundancy by blocking redundant links loop-free.
That last one, definitely the last one. It provides redundancy by blocking redundant links in a loop-free manner.
Right. Classic STP.
Classic and critical. This is all about network redundancy and loops. You want backup paths in your Ethernet network for reliability.
But if you just plug cables in to create loops, you get broadcast storms and chaos.
Exactly. Total network meltdown.
Yeah.
STP is the protocol that intelligently figures out which links are redundant and blocks them, creating a single active path. If the main path fails, it can unblock one of the backup paths.
So it gives you redundancy without the loops.
Precisely. Now, it's important to remember STP isn't primarily about finding the fastest path like OSPF. Its main job is just preventing those layer 2 loops while still allowing for backup links.
Got it. Loop prevention first. Okay, final question, number 10. Back to troubleshooting commands. Which Junos OS command views the operational status of a specific interface? Options: show configuration, show system status, show route, and show interfaces.
This one's show interfaces. Absolutely essential command.
Show interfaces.
Yeah, for network interface troubleshooting, this is often your first stop. It gives you so much detail about an interface's state.
The explanation agrees. Shows operational status, stats, like is it up or down, any errors, how much traffic.
All of that. Physical status, logical status, error counters, traffic counts in and out. It's packed with info. If someone says I can't connect, show interfaces on the relevant ports is usually one of the very first things you check. It can point you towards physical cable problems, config mismatches, errors, all sorts.
Okay, wow. In today's world.
Yeah. Security, automation, scale.
Right. And how could digging deeper into Junos OS and to Juniper's way of doing things maybe provide some answers or new perspectives on tackling those challenges?
Definitely something I'm all over.
Food for thought.
Well, thanks for taking this deep dive with us today.